Hi class, I wanted to do an example of how we can use a frequency distribution, like we do in chapter 20.3, to construct 4 different types of visualizations or displays of our data. First one, a histogram, followed by a frequency polygon, a circle graph, and a stem and leaf plot. So in the first example of this section, notice that we had created from our data of test scores 1, 2, 3, 4, 5, 6, 7 classes of data, and we had these frequencies. Well, our first step, if we wanted to create a histogram, would be to create our y-axis and our x-axis. So our vertical axis is always our frequency, and our horizontal axis, or our x-axis, is always our class midpoints. So we first had to find the midpoints of every class, as we did in our last example. 35.5, 45.5, 55.5, 65.5, 75.5, 85.5, and 95.5. Next up, we will create basically a bar graph, but a histogram is special in that each bar must touch. So we begin, and for our first bar, our class midpoint of 35.5 has a frequency of 1. So our first bar has height 1. Our second bar, containing the midpoint 45.5, has a frequency of 3. So our bar touching goes up till 3. Our next bar as a class midpoint of 55.5 has a frequency of 3 as well. Our next bar, class midpoint of 65.5, has a frequency of 6. So we go up to 6. Hopefully your bars aren't leaning like mine are, but you get the idea. Our next bar has a class midpoint of 75.5 and a frequency of 2. Our next bar has a class midpoint of 85.5 and a frequency of 3. And our final bar has a class midpoint of 95.5 and a frequency of 2. So again, a frequency distribution can lead us to a histogram. Bar graphs where all bars touch, the horizontal or the x-axis is made up of class midpoints, and the vertical or the y-axis is your frequencies. Again, you can scale those accordingly to your frequencies. Ours were easy to do by ones, so that's why I chose 1 as my scale. Once we have a histogram from our frequency distribution, it's very easy to construct a frequency polygon. All we need to do is connect our dots, with our first dot being at the very beginning of our first bar, and then each of the next dots will be the height at our class midpoints. So at 35.5 we're at 1, at 45.5 we're at 3, at 55.5, 3, at 65.5, 6, at 75.5 we were at 2, at 85.5, 3, and at 95.5, 3. Finally, we connect all of the dots starting at the beginning of our first bar and ending at the end of our last bar. So what we create is a polygon, a closed object. If your base is here, it's a polygon, and it's a frequency polygon because its height continues to change based on the frequencies. So that's our second type of graph. It's very easy to construct from a histogram. Next, we would like to talk about a circle graph, or a pie chart. In order to do that, though, we first begin by changing our frequency distribution into what we would call a relative frequency distribution, by getting the percents of every class. So here our frequency for the first class was 1, but there were 20 items to begin with. So 1 out of 20 gives us our percentage of 5%. Next up, 3 out of 20 gives us our percentage of 15%. Another 15% for 3 out of 20. 6 out of 20 is 30%. 2 out of 20 is 10%. Again, 3 out of 20, 15%. And 2 out of 20, 10%. Notice if we add up these percentages, their sum should be 100%. So now it's just a matter of creating a circle graph based on those percentages. An easy way to do that is to divide the circle in half, so there's 50% here and 50% there. And now we notice that we have a class here of 30%. That was our modal class, right? And we have another class of 10% and 10% here. So together, that's 50%. So if I look at my graph here, I could cut this in half, this half in half, and have 25%. Or I could cut it a little bit bigger and say this looks approximately like 30%, which would be represented by our class, our modal class 61 to 70. Cutting that in half again, since there was 20% left here, would be 10% and 10%, which would be represented by our classes 71 to 80 and 91 to 100. This is just one way to divide this up. Then we also noticed that we had, looking back at our chart here, we had three 15%, 15% here, 15% here, 15% there, for a total of 45%, and then we have this remaining 5%. So if we simply divvied this up into another 30% chunk, and then divided that into pieces, right, we would notice, for example, that half of 30 would be our 15%. Another half of 30 is 15%. And then a little bit left over. Maybe it's a little much, but we're eyeballing it, so it's difficult. Maybe more like that. It's another 15%, leaving us with our 5% here. So each of these 15% would be our 51 to 60 class, then our maybe 41 to 50 class, and then, of course, our 81 to 90 class. Our 5% was 31 to 40 class. So that's a rough idea of how we could get a circle graph. You can be much more precise using a protractor and a compass. Finally, we'd like to create a stem and leaf plot from our frequency distribution. And to do this, we first need to have a stem for every single 10 place. So like 30s, 40s, 50s, 60s, etc. So 3, 4, 5, all the way down to 10. Those are our stems. Our leaves are the digits without commas. So for example, looking at our original data, this is where we have to be a little bit careful. Going back to the original data, we did have, in fact, a 36. And so because we had a 36, we would put a 6 there. We also had a 45 and a 49, so 45 and 49. We also had a 50, a 55, and a 58. A 50, a 55, and a 58. Notice there's no commas in between them. We also had a 60, a 63, a 64, a 65, a 68, and a 69. That was our modal class. We also had a 70, a 72, and a 74. 70, 72, 74. We had an 81, an 82, and an 85. A 95, and a 100. So that is our stem and leaf plot. Again, noticing there's no commas in between your digits. And if we had repeated any test scores, we would have had a number repeated. For example, had there been two 95s, this would have been 5 and another 5. And we always put them in order from least to greatest. Also note that if we had missed one of these stems, like if there were no 40s, we would still write the 4 for the stem, but leave the leaves blank. Putting a 0 under that leaf would mean that you had a score of a 40, not that there were no 40s. So that's really important, a distinction that's really important. I hope this helps make more sense of how we can use our frequency distribution to create both a histogram and a frequency polygon, a circle graph, and a stem and leaf plot. Good luck practicing.